Hey guys, this is the activity of the week of September 19th. These videos are a way for you guys to see how to do the problems. I'm going to work each one and get to the answer. I will also send in the announcement a photo of the answers if you guys are just wanting to look for that. However, I am going over each question, so if you need help with a certain one, you can always just skip to when I'm working that. So let's start with one. To solve this system of equations graphed on the coordinate axis below. With this, they're wanting you to see that these two lines have intersected right at this point right here, which the point is 5, -3. This is where their x and y values are the same. This one is they just want you to see where this intersection happens. Okay, question 2. To solve the following system of equations graphically on the set of axes below and state the coordinates of the solution. Now, just like the first problem, they're wanting you to graph each equation like they did and see where this intersection occurs. So, we're going to graph this first equation here, which should get you the, so the intersection would be -8. Right. And then another where this graph kind of runs through is -8, -2. And then by adding a line, I'm going to use this ruler just so we make sure it's pretty even. So there's that first line. Okay, and then we are going to do the second here, where we can graph the y-intercept first. So that gives you 0 and 2, right there. And it just so happens that their next point, when you graph their graph this equation, you also get the -8 and -2. Just to make sure this kind of makes sense. Alright, so for this one, as you can see, where that intersection occurs, so right here we're just going to put it with the purple. So right there is where the intersection happens. So that's when you're just plotting the points. So that is -8. -2. Now you can decide if you want to plot more points than what I did. I kind of just did the intercepts first, a little in between. I'm just kind of shortening it just for this video, so I'm not explaining each point. But you just graph each equation. So for number 3, it's asking for the same thing. I do recommend for this one to get it into your slope form, so that gives you move the x over here, so y = 3 - x, so that gives you the other equation. So that y-intercept for this one, we'll just start it with this one, that 0, 0, 3, right there. Actually, I switched those up. 0, 3, sorry, this way. And another point that it also crosses is 5, -2, which these are points that you'll notice when you graph these. I'm just going to kind of shorten it for the sake of the video. So when we graph this, I mean, you're welcome to grab a ruler if you want. It's pretty, it doesn't matter exactly how you do it. But I'm just doing it for the sake so you guys can see where the intersection is actually occurring. So this one, we're going to work on that one. So their y-intercept here is 0, -5. And you will notice when you plot these points, they also cross here. Okay, and then we get that purple, just so we can see where the intersection is occurring. So the intersection is occurring here at -5 or +5. Sorry about that. Again, I will be posting the answers. So if I say something different than what I'm meeting, just whatever I write. So 5, -2. That is where the x and the y have the same value for each equation. Now to 4. Number 4 is determining if the following system of equations has no solutions, infinite, many solutions, or exactly one solution. Now, we know that it's not infinitely many solutions. This is because neither of these are a multiple of the other. It does kind of get close, where they could be multiple of 2, but it doesn't match up where it's not the same equation. So, this is where we recommend that you just kind of solve it. I would use elimination for this one. So, what we can do is multiply this one by -2. So we can get that -2y here. So I'm going to move this kind of to the side so we can work on it on our own. So we get -4x plus -2y equals -14. And then we have that same one, 3x plus 2y equals 16. Now we're adding these two. These drop out from each other, and this gets us our -x equals 2. Now, we divide by that -1 from both sides, so we have x equals -2. Now we're going to plug this in. I prefer to plug it in to the other equation. So 3 -2 plus 2y equals 16. So we want to get to that y. Plus 6 or 2y equals 22. Divide by that 2 on both sides. We get y equals 11. Now you see that we do get a solution. So it would be one solution because we got a solution. Okay. Now, number 5 is find the solution of the system of equations. It wants you to determine if you're going to use elimination or substitution. I'm going to hope that you guys saw that these will help in an elimination. So we're going to just cross those out immediately. And we write this so we don't get them confused. So we're left with -10x equals 5 and -4x equals 23. Your usual elimination. We're going to add these together. I get this -14x. Divide by -14. Get you your -2 equal x. And then we plug this in. I usually just plug it into here, but you can plug it in whatever equation you want, as long as one of these two. So we have -4 and then -2 plus 5y equals 23. This gets you your 8 plus 5y equals 23. Subtract the 8. 5y equals 15. Divide by 5. Gives us y equals 3. Now, I'm saying you can leave these answers like this, or you can also list them as ordered pairs. Really depends on what your test is asking. So this one doesn't really have anything specifically. So you can either write it like this or write it like this. So number 6, again, it's letting you choose over substitution or elimination. This one can be a little tricky because it's not giving